So in this screencast we're going to look at Hello World. So this is the first computer program that pretty much everybody writes when you're learning a new programming language, and it simply displays a message or just a string of characters, or even we just call it a string, to the user. So this is usually in a computer terminal on a PC. So as you can see here, suppose we've got our program called helloworld.exe. We'll execute that compiled file, and then the string hello world will appear in the terminal. So we'll look now at the actual kind of source code for Hello World. So we'll first look at the C++ version. So the command that we use for printing to the terminal is called cout. So you can see that appears here. So it is cout, and this part. So cout is part of the IOStream library. So to be able to use that, we need to put #include IOStream at the top. So remember these, it's not brackets here, it's these triangular symbols, I can't remember what they're called now. So we need to use those to include IOStream. So remember, this is a #include is a preprocessor command, so when this compiles, it'll pull in all the contents of IOStream into our source code. And again, we can see we've got our main function here, and inside the main function, so in between these curly braces, we've got our source code. So IOStream itself is that's a part of the standard std namespace, and so we need to use this syntax here before cout. So std : cout, and again we've got these symbols here to say hello world. So inside our string, so we start our string with curly brace, the double quotes. So again, it's not single quotes. You have to make sure that you use double quotes. And at the end of that statement, we just put the semicolon in. So this is, you have to put that at the end of most C and C+ statements, or else you'll get an error when you try and compile. So you can see this source code is very simple. So if you compile and run that, it'll print hello world into the terminal. So we use G++, since this is a C++ file. We're going to use G++. We'll turn on all warnings, some levels of optimization. We'll define our output file to the helloworld.exe. So when we compile that, it'll create this executable. So we can run it, typing in this command, and again, when that code executes, then the message will be displayed in the terminal. So now look at the C version of Hello World. So this is fairly similar. So we can see we've got the same same definition for the main function is there. We've got our opening curly braces and our closing curly braces. But now this will be in a file called main.c. So because this is a C version, we'll use the C file type. We can see now, so IOStream is not part of C. So the equivalent library for C is stdio. So the standard output library. So we need to include, #include that into our source code. So again, when we compile this, the preprocessor will run, it'll pull in the contents of stdio.h into our source code, and so we'll be able to use functions that are in that library. So the function that we use for printing strings in C is printf. So similar idea to cout. This is kind of like the C version, if you will. So you do printf, open bracket, again our string, note the double quotes, it's not single quotes here, it's a double quote symbol. Close the brackets, semicolon. So again, this is a C equivalent to this. Sorry, that's a C equivalent of Hello World to what we saw before. And again, because this is a .c extension, we know that it's a C source file, and so we compile it using GCC rather than G++, remember. So G++ is for C++, and GCC is for C. So again, we'll just compile it pretty much in the same way. So we use GCC and switched on all warning some optimization. We set the same output executable name, and then now our source file, our input file is main.c. Compile it, run it, and we'll get the message to appear. So that's a very simple example of a program. So we've seen it in both C and C++. So we'll look now a bit more into the difference, because C++ is what we call a superset of C. So, C++ was an extension on C. So it also includes C itself. So all C code is by definition also C++ code. So you can see here, C++ encompasses C. So everything, all different commands what are part of the C language are also part of the C++ language. But it's not, it doesn't work the other way around. So C is not a superset of C++, so C is only a subset of C++, and so we can only use the functions that are part of the C language. So any functions defined in C++, any commands what are just strictly C++ language features, we cannot use in C. So we can only use these ones what overlap. So in the case of the previous examples, we can use printf in both C and C++ programs. So printf is part of the C language. So this just means by definition it's also part of the C++ language. However, cout is just C++ only. We cannot use cout in C programs. So if you want to use printf in C++, again, so this will be a C++ main file. So we've got main.cpp. So instead of using IOStream, remember in C, the version we used was stdio. So this allowed us to use printf. But the C++ version of that library is just called cstdio. It's exactly the same. They just have a different naming convention. And this convention applies to all C libraries when we're using them in C++. We just get rid of the .h. So just get rid of the .h and we just put C in front of it. So that's how you translate between the different file names. So here we can just include cstdio, and then we can use printf and our C++ source code. So in general in this course we are going to be using printf instead of cout, even when we're using C++ code. There is a very good reason for this, and it's basically because IOStream is much larger than cstdio. So it means that the resultant executable is of a larger size when we use IOStream, and RAM usage is also greater, because we know if you do hash include IOStream in your source file, it'll pull in all the contents of IOStream. And if you do hash include cstdio, it'll pull in all the contents of cstdio. And just because IOStream is much bigger, when that gets pulled in, it just kind of bloats the size of our file. And then when it comes to run as well, the RAM usage takes more memory to run cout than it does printf, if you will. So this is not an issue. If you're doing code on a PC, we're not bothered. It's only a few, 100 kilobytes maybe, just a few kilobytes of RAM difference. So if you run on a PC, got gigabytes of RAM, maybe a terabyte hard drive or something, this kind of bigger size is completely negligible, doesn't really matter. And in those cases, you're probably better off using cout when using C++. But we're going to be writing code that's running on microcontrollers. So we've got that's a much less disk space. Say the flash, you might have 1 megabyte, maybe half a megabyte of flash memory. So that's the kind of equivalent of a hard drive. So compare that to a terabyte, is obviously a huge difference. And again, rather than gigabytes of RAM, we've got 32 kilobytes of RAM. So even a few kilobytes difference, it does make it's a large chunk of our RAM. So we'll be using printf rather than cout when we're writing C++.